Hi everyone, welcome to the video on displaying quantitative data. In this video, we're going to focus on how to make a histogram, what a histogram tells us, specifically about the distribution of the data. To begin, we have to talk about what a variable actually is. So a variable, in terms of statistics, is some type of characteristic that we can record about an individual, meaning a person or let's say a month of the year, that can vary, right? That's the important part, that it can change over time. So for instance, your age or your height can change over time. That would be a variable. But there are different types of variables. We can distinguish two types of data. When we have categorical data, categories kind of sort themselves. These types of variables would be what type of pet do you own, right? There's no number associated with that. We're not talking about the number of pets, we're saying the actual type of pet. We couldn't order rabbit, dog, cat, goldfish, hamster, right? These are just categories. One isn't more than the other or less than the other. What we're going to work with is quantitative data. And when we're dealing with this, there's really no obvious way to choose how to sort the data. And you'll notice that there will be a choice. So for this example, we're looking at the magnitude of earthquakes. Earthquakes each have a certain magnitude, and that magnitude is signified by a number. Now, the reason we said that there's no obvious way to sort this data, obviously magnitude can increase or decrease, but what we're talking about is little bins, right? So look at this histogram. Histograms are made up of these bars, and each bar is considered a bin. Each bar consists of a certain range of magnitudes. So it looks like on this one, between 5 and 6, there are 5 bars. So I'm thinking that that bar right here would be all of the earthquakes from 5.0 to 5.2. Let's talk a little bit more specifically about histograms. So these are displays that allow us to see the distribution of data, and that's why we like to use histograms. We can see if there's any gaps in the data. There actually are some right here. You'll notice that they're tiny little bars, but there's a gap between these two and a big gap between these. And we're going to come back to that in a moment. We're going to see big bars right here. Those are going to be modes. We're going to see if this is symmetrical. Maybe it's skewed in one direction, like I think this one is. And basically, this distribution is going to let us see what the typical value of an earthquake is, right? So I would say a typical earthquake is about 7.0. It is very, very important to note this last bullet point. Every bar is the same width, right? Remember I talked about bins. They have to be equal width to be a histogram. And the other thing is that these gaps, right? These are actual gaps in the data. A bar graph is different from a histogram. I'm going to go back for a second, right? So look at these pets. These little gaps here are to separate those categories. Gaps in a histogram are actually gaps in the data. So how do you choose that bin width appropriate for a data set? Well, take a look at this right here. If we change the bin width of magnitude to a much smaller value, these get very, very spread out. Looks like we have lots of gaps in here, right? It looks like we still can see that mode, which is nice, but this isn't as useful as the previous graph. If we go the other way and we make those bins much, much wider, now that doesn't tell us much either. We can still see the mode here, but we can't see the outliers anymore. So we're missing information. So when we choose a bin width, we want to make sure that it's not too big, not too small, and that it allows us to see modes if there are any, gaps if there are, or these are going to be called outliers out here, right? Gaps in between them. And we want to see that shape. So these would not be appropriate. When we talk about distribution, we're going to focus on 3 main ideas. The first one being shape. I've already alluded to these things like symmetry, the mode, the tails, anything unusual like the gaps or the outliers. The second category will be center or the typical value. We might use the mean or the median. Maybe we're going to see if there's another type of value that would represent a typical center or typical value. And the last category is spread. So we might know that there's a lot of earthquakes that are 7.0 or between 7.0 and 7.2, but are they really, really clustered around that, or are they very, very spread out, right? So the spread is very important. The range, we could see what the lowest and the highest is, but we're really going to refer to variation or how spread out these things are with some numbers. We're going to get to that in another video. But let's talk about some of these a little bit more specifically now. So when we're talking about the shape, we said that mentioning what the mode is very important. And we can have different types of modes. Think of them as the humps in histograms. Sometimes we don't really see any, right? Like this one here, yeah, maybe this bar right here is higher than the others, but not really. Overall, I'd say these are very close together. Maybe it's a uniform. Maybe there is no mode. Maybe there's one big bar, right? One big hump here. We'd say that's unimodal, has one mode. We could have histograms that have more than one mode. For instance, this has two, right? These two big bumps here. We'd say that's bimodal. These are the ones that we're typically I'm going to say. In terms of symmetry, a graph can either be symmetric, right? Where if I folded it along some value, it looks like the left side would match up with the right side if we folded it. We could see histograms that are skewed left. This one in the middle is called skewed left because there's this, what we call a tail over here. There's like, you can maybe say that these are outliers here, very few values, but they are very, very low. Or they could go the other way. We could skew right where the tail's over here to the right, kind of pulling that data. And then lastly, for shape, we would mention any outliers. Those would be any data points that are far away from the cluster of data, and then any gaps in between those. For the center, remember that's the typical value of the data set. We would think about what the median is. So the median of this histogram actually is 7. Remember, that's not because this is the mode, that's actually the middle of the data, meaning that to the left is 50% of the data and to the right is the other 50% of the data. If this was unimodal, as this graph is, notice that these are pretty close. I would say that the mode and the median are very, very close together. If it was not unimodal, right, your modes could be on the different extremes and the median be in the middle, they would not be so close. We will come back to the mean in a different video. And then the last category of spread, we do look at the range, the max value minus the min value, right? We could do that subtraction and get a single value. That doesn't always tell us everything. So if the range of something is 100, say for test scores, versus 50 for a quiz score, right? Does that really tell us about the variation though in the scores? Like obviously we can see that they have a min and a max, and the data is spread between those, but range typically isn't that helpful. We care much more about the clustering, because if things are not clustered around the center, let's say that they are more varied, right, then the less the median is going to tell us about the typical value. And we're going to spend an entire video talking specifically about that variation. Something that we do find more useful is called the interquartile range. We're going to just refer to that as the IQR from now on. So instead of the spread from the min to the max, let's just focus on the spread of the middle 50% of the data, right? So we can ignore the extremes that are really low and really high. The way that we calculate that is to find first the median. We would then find the median of the first half. That's going to be called Q1. So that way 25% of the data is below that. We would then find the median between the median and the maximum value. That would be Q3, where 25% of the data would lie above. right there between Q1 and Q3, right? If you take that difference, that's going to tell you the interquartile range. So if you figure out that the interquartile change is 1 compared to the range, which might be 5, that's going to tell you a lot more about the clustering. You're going to say 50% of the values have a range of 1 compared to 100% of those values having a range of 5, right? That's very, very good data to have. So something that we also find useful is seeing all of those things put together in a little chart. We call it the 5-number summary. So that's where we'll say what the min and the max are. We'll say what Q1 and Q3 are, and obviously the median, right? So then if I can see those 5 values, I can see that spread. So let's just go through an example. If we were looking at airline flights, let's say we wanted to take some data about cancellations. So how often are flights canceled? We would need to gather some data, right? Well, what's the variable? Well, there's a few things that we would need to identify. I know we're not talking about people, so we're really talking about time, right? So let's break it down into months. How often are flights canceled? Let's look at how many flights are canceled in the month. And what are we going to be looking at? Well, let's look at it as a percentage. So in the month of blank, this percentage of flights were canceled. Let's kind of limit ourselves because that would be crazy if we looked at all time. Let's look at a 10-year period, let's say 1995 to 2005. And let's also limit it to just US airports, right? So it's nice to think about who, what, where, and when we are considering what that variable will be. So in summary, let's say it's the percentage of flights that were canceled at US airports each month between the years 1995 and 2005. Right, that's very specific. We know exactly what that is, and we know that it will vary every month. It's also important to note that percentages are quantitative, right? So remember we talked about categorical and quantitative data. So because we're dealing with percentages, we have verified that it is a quantitative set of data that we are dealing with, so a histogram would be appropriate. Okay, so let's show that data turned into a histogram already. Let's just say that this was an appropriate bin width, right? We're just going to analyze the distribution of this. So it looks like we have a range here from 0 to a little bit above 20% of the flights canceled. Remember, that's within a month, right? So we're totaling up how many months had that percentage canceled. So it looks like this is 0 to 1%. 1 to 2%, very, very tall. I'd say that's definitely a mode. This is a unimodal distribution. And we also have this outlier over here at 21 or 20%. Something weird must have happened in that month. I'm guessing that's only 1 month, right? Look at this, very, very few months were above 5%. So we would summarize all this, right? And we want to mention those 3 categories: shape, the center, and the spread. We want to make sure that we hit upon all 3 of those categories when we describe this. So in our interpretation, we would say that the distribution is skewed right for a shape because of this outlier over here. So for the center, let's just pretend that you calculated these. We would mention what the median is, and the median would be an appropriate center to use because this is a unimodal distribution. And we could also calculate the IQR, which is very low, right? A 1% spread for that 50%. So we would mention something about this. The low IQR indicates that most months, the cancellation rate is very close to that median. In fact, right, remember that this IQR is 50%, so let's mention that specifically. During 50% of the months, it's between 1.4 and 2.6. Right, so that the only reason that we knew that, right? Remember, somebody had to go through these calculations. They already figured out this IQR. That was an actual calculation, and in only 25% of the months, it was more than 2.6. That's the part above the Q3. That's over here. These are all things that we could have said just by looking at the picture, but now putting it into words is your interpretation, right? And we want to do that thoughtfully. And then the last part we want to mention is that outlier. This outlier turned out to be a 20.2%. And it turns out that occurred during September 2001. So that can be explained by the attacks on September 11th, which shut down air travel for several days. So typically with outliers, you try to come up with a reasoning for that, especially if you go farther in your data analysis. Sometimes we eliminate outliers completely. We know that they're totally going to skew the data, and they were very special circumstances. All right, so in class, you're going to be talking much more about how to actually calculate these things, or practicing calculating these things and practicing making the histograms, but more importantly, interpreting what the distribution tells you. Good luck.